Hello and welcome. So this video is going to be kind of a supplement to the CCNP security VPN cert guide that I mentioned in the previous video, and mostly just to show like a complete working example, and also mention a couple mistakes that I had originally made, and a good reference for someone trying to get a working example. So let's go ahead and get started. So in this one, I'm going to do DMVPN. It's going to be using the IKEv1 VPN tunnel and Phase1, which in the DMVPN terms is a hub and spoke setup. So in later videos, I'm planning on doing configurations that use IKEv2, and then also get into phase 2, which allows the spokes to create dynamic tunnels and communicate directly between them. But for this video, this is just kind of the beginning, the phase 1 hub and spoke model. And then so essentially what's going to happen on this is the R1 and R2 routers will be able to communicate over the DMVPN, but that traffic's always going to be routed through HQ for this example. And then we have this ISP router, and it has links to HQ, R1, and R2. And so ISP to HQ is on this. These are considered the public IP addresses. This ISP router is meant to simulate an actual, like internet ISP. So we have the links from the ISP to the various public IPs and outside gig00 interfaces for HQ, R1, and R2. So HQ is on the 30.50.60.0/30. R1 205.30.1.0/30, and R2 is on the 168.5.10.0. And then for each for the HQ, R1, and R2, they're all going to have GRE tunnel interfaces. They're all going to be on the same subnet, 192.168.10.0/29. The HQ is going to be on the .1, R1 is going to be on .2, and R2 is going to be on .3 if I remember correctly. And then in this example, R1 and R2 are going to have LAN segments, and then we'll have the Linux hosts that are going to be get connected to those, and they'll be able to just use those to simulate traffic like in the previous videos. Okay, so I'm going to start off on the HQ router, and most of this I'm just going to be pasting in. Gig00 is the public or internet facing interface. Gig01 is going to be the I'm not actually going to use it in this case, but this would be if we wanted to put a LAN subnet on HQ, then it'll be there for us. But in this case, I'll configure it here, but I'm not going to use it in this particular example. It'll be there if I want to modify it for later, though, which I probably will. And then also something that I wanted to do before I get too far into this, I want to actually see some debug messages. So I'm going to do HQ router here. So I'm going to do debug, crypto, ISACamp, debug, DMVPN, all. and I want something else. We'll just go all for this one. And we'll do debug and HRP. This may just generate way too many messages, but I find it interesting to see what messages show up once you get the configuration running. So we've got debug running on here, and we'll see what usefulness we get out of that. Okay, so we got the interfaces, gig00 being on the ISP, gig01 there for a LAN subnet if we need to use it. Not going to do that, as I mentioned. And then so this is IKEv1. So we've got phase 1 policy for IKEv1 tunnel, and then a phase 2 transform set. And we have the Ipsec profile, which we're going to reference in the GRE tunnel interface configuration, and just basically saying we have this Ipsec profile, and we're going to reference the phase 2 transform set. So it lets the GRE tunnel know that it's going to use this encryption and hash to protect that traffic. And then, so we have a phase 1 policy, we have phase 2 policy, we have an IPsec profile that references that phase 2 transform set, and we need pre-shared keys for the 2 spoke routers. So we're going to be building separate VPN tunnels with the 2 spokes, and then so we've got a pre-shared key for each one of their public addresses. So R1, let's see, R1 is the 205. So this would be the key, pre-shared key for R1. This is a pre-shared key for R2. Router, we're going to have EIGRP. And since this is the HQ and I'm not using the LAN subnet, then the only thing I need to have in EIGRP advertised is this tunnel interface. And the reason why that's necessary is because there's not going to be any dynamic routing happening from the ISP to HQ R1 and R2. This is effectively static routing, meaning to simulate a real internet connection where we're not going to have EIGRP going across the entire internet here. It's just the EIGRP is going to go through the GRE tunnel, which is protected by IPsec. And so we need this here to make the adjacency between HQ and R1 and then HQ and R2. And then again, since we're not doing dynamic routing as far as the WAN links go, then this is just like a default route out the gig00 interface. And then next hop is the public IP for the ISP on this particular link. So paste in all the crypto stuff. And paste in the routing stuff. And then now we're getting into creating the tunnel 0 for the GRE interface. And basically, as I said, all these tunnel interfaces are going to be on the 192.168.10. They're all going to have a source of their gig00 interface, which is for essentially internet facing. The GRE Multipoint. So if we go into the documentation here, and I'll put a link to this in the video description. I'm also going to put a link to Rob Riker and Kevin Wallace's channels, because they have good videos that help as a supplement to this this guide, which is good to a degree, but it doesn't give you everything you really need to actually build a complete lab that works. And so anyways, I've found a lot of value on their channels for sure. So tunnel mode GRE multipoint sets the encapsulation mode to MGRE for the tunnel interface, and that way, the way I look at it is, this is the command that'll allow this tunnel interface, since it's HQ, to be able to have multiple spokes, and there's just going to be 2 spokes in this example. Tunnel key. So it says enables an ID key for a tunnel interface. It's got to be set to the same value on all hubs and spokes in the DMVPN. And apparently some of the platforms you're not supposed to use it, but so we got that. The NHRP authentication. Let's see where that's at. Configures the authentication string for interface using NHRP, and it must be set to the same value on all hubs and spokes in that same DMVPN. So we got that. And then multicast dynamic allows NHRP to automatically add the spoke routers to the multicast NHRP mappings. And let's see, network ID enables NHRP on an interface. And then we get into the byte size of MTU and for TCP. So let's see. Okay, so IP MTU sets the maximum MTU in bytes of IP packets. So this is more like layer 3. We're dropping it down, like normally that would be 1500 bytes. Now we're dropping it down by 100 for that, for the GRE encapsulation. And then if we go down a little bit further, the IP TCP adjust MSS, which is max segment size. So now we're talking layer 4 for TCP. Adjust maximum segment size value of TCP packets going through a router. And then recommended value is 1360 when the MTU is set to 1400. So a lot of the examples that you'll see on videos are in the Cisco cert guide's going to mention this, and then Cisco is making it easy for us here when they're just giving us a recommendation for this type of like for DMVPN. They're just giving us the recommendations for these 2 commands. And then TCP sessions quickly scale back to 1400 byte IP packets, so the packets will fit in the tunnel. And then no IP split horizon. We want the EIGRP that's going to be going on between R1, HQ, and R2. Any routing updates, because everything's going to be going through, this is, DMVPN phase 1, so everything goes through the HQ router. It always goes through the hub. And if we learn something on EIGRP on an interface, we want to be able to send it out that same interface. And then, so we need to like turn off the split horizon, so that anything that's learned on an interface can get sent out the same interface. And then tunnel protection. So like we want this GRE tunnel to be sent over this IKEv1 Ipsec tunnel. And so then we created that profile earlier. Thing I'll mention is you really want to, so the first kind of mistake that I made when I was trying to set up this lab to begin with was I wasn't using static routing in the ISP. And I had like conflicts between the EIGRP that was meant to go over this tunnel and what was just happening over the ISP links, and it kind of messed everything up. The second main thing that I noticed is to make sure that, I mean, it makes logical sense to begin with, but especially for this, like make sure all the crypto stuff is already configured in on the router before you reference it in your tunnel protection IPsec profile. Because what's going to happen if you don't do that is when you put this in later, you'll find that like say if you didn't put this on, or you put this on like a spoke, and but you put it on before the actual profile was defined, then if you do that on a spoke, then you're going to find on the HQ router that you're going to see console messages that say that it's seeing packets that are not protected by IPsec. And so basically what's happening is the HQ router has this profile, and it's expecting stuff that's coming across this GRE tunnel to be protected by IPsec, and then it's getting packets that are not. They're just clear text packets. So if that happens, even like, so on the spoke, even shutting off the tunnel interface and turn it back on doesn't really proc the crypto. So what I found is I'll actually go into the tunnel interface configuration, take this off, take this command off, say no to it, and then put it back on, and then boom, it'll work. But so at any rate, just make sure that all your crypto stuff is in the router configuration already before you reference it, because otherwise you're not going to get that between a spoke and the HQ or the hub router. The VPN tunnel is not going to form, even though the GRE tunnel will be up just fine. So I'm going to paste this stuff in. And then as soon as I do that, I'm starting to get NHRP messages from this configuration that was done. Crypto is on now because I've ran this command, tunnel protection, that enabled ICE account. Okay, so now we'll go to the ISP. And then this is just going to be really simple. Again, no dynamic routing. These are all just going to be connected routes. That way, R1, HQ, and R2, their gig 00 interfaces are all reachable at this point, and no dynamic routing there. Again, the only dynamic routing, the EIGRP, is going to go across the GRE tunnel protected by IPsec, which makes it, in this case, DMVPN. So we got the ISP router configured, and then switch over to R1. Get these interfaces up. One for the WAN link, one for the LAN subnet. So in this one, this is a spoke. So we just need the pre-shared key for the peer IP of HQ. So all the same crypto stuff. And then for EIGRP, the network for the tunnel interfaces, so we get adjacencies, and going to advertise the interface for the LAN subnet. And then again, static routing, so default route out the gig 00 interface to next hop of the ISP. And then move on to the tunnel interface. Let's see, do we have a key in this other one? Yeah, we did. Okay. So I think the only commands that are going to be different on this one are these three. I think all the other commands are exactly the same. So if we go to the documentation, so it's just going to be these ones for NHRP. So in this one, we're specifying the IP, NHRP, map, multicast, and then the public IP for HQ. So in the case of the hub or HQ, that was multicast dynamic. So on HQ, it was multicast dynamic. But on a spoke, where we're just doing spoke to hub only, then we're specifying the hub router here. And then let's find the map description. Actually, what I need to do is go to, this is what I was looking at before, is configuring the hub. So now I'm going to go to the top of the documentation, and should be a link for configuring a spoke. Okay, so now I'm on the spoke. So I'll go over this again, since I was in the wrong place. IP, NHRP, map, multicast, and then the hub physical IP address. So we got that here. We're just specifying, hey, R1 is a spoke, and then what's the public IP of the hub or HQ. Enables the use of dynamic routing between spoke and hub, and sends multicast packets to the hub. And then IP, NHRP, NHS. This is going to be the tunnel IP for the hub or HQ. So it says configures the hub router as the NHRP next hop server. Since it's in spoke and hub setup, always wanting the hub to be the next hop server. for this particular example anyways. And then one more map command. Oh, and then I skipped over this one, tunnel destination. When you get into phase 2, and we're gonna, like in later examples when we're gonna do where like R1 and R2 will be able to make a dynamic tunnel between them directly, and not going through the hub, then it would be set to GRE multipoint. But in this case, we're really just doing strictly hub and spoke, then tunnel destination, and then the hub's public IP address again. So basically, similar with the multicast command, then we're saying an explicit tunnel destination here. And then the next one, I think the last one to really cover on this one for a spoke, is this map between basically just saying, so we've kind of identified the public IP of the hub HQ, and we've also identified the tunnel IP for HQ. And for the NHRP database, we want to tie these together. So it's like, for the hub, here's its public, and here's its tunnel IP. And that should be in here somewhere. NHP map. Okay, so IP NHRP map, the hub tunnel IP, and the hub physical. Like I was saying, statically configures IP to NBMA. Hub tunnel IP address defines the NHRP server at the hub, which is permanently mapped to the static public IP of the hub. So I'm sure you get the point here. And then the rest is the same. And also some kind of just copy and paste of DHCP stuff that I've been doing in other labs. And the purpose of that will be just to have this Linux host be able to come up and get DHCP. So I'm going to paste in the tunnel config. We can see, so tunnel interface came up, and this is the key thing that's helping to know this is going to be working, is like, so the tunnel interface is up, and we got that EIGRP adjacency that I was mentioning earlier. And so I'll go in and put the DHCP config in. So typically in CML, what I prefer to do is, like, if I'm having a router or switch have any DHCP configuration, I'll get that running on there, and then after I do that, then I'll make the link, and then I'll boot up that node, and then that way, as it boots up, it really should get the DHCP assignment without any issues. So at this point, let's see if I can still see any of the. Okay, so we had, going back to now the R1, R1's configuration was totally done, and this is kind of the purpose of why I had DHCP running on this, is because, debug running on this. So after I put in the tunnel config and the whole config for the router, there was some messages along those lines, and then we saw ISACamp come on, and then like I was saying before, you'll see that message about not an IPsec packet. My guess is the tunnel actually has built on here. And well, in fact, I'm positive it did, because I saw the adjacency. But I think this message right here about not having an IPsec packet was I mean, literally just in the, probably less than a second of a time of this tunnel configuration being up, but not yet having the protection command. So at any rate, right after that, because you can even see that quite clearly in here, because like right here it's talking about it saw something come across the tunnel that wasn't protected by IPsec, and the reason for that is because it hasn't built, like the VPN tunnel hasn't built yet. But then now we immediately start seeing those messages. I'm starting to see IKE messages, so we know the tunnel. As soon as this tunnel protection command went in, the VPN tunnel started to build. It shows, this phase 1 policy came across. It's getting into main mode 2, main mode 3. Pre-share key matched from R1. See, that's R1's IP, yeah. So, and it makes sense. R1 was the initiator here. So we got the pre-shared key matched, and then eventually it's going to get completely done with phase 1 and get into phase 2. So we start seeing messages about phase 2 SA. And then the timeout kind of, we may have lost some of the debug messages, but you can definitely see it's getting into IPsec here. And then now as the timeout came up and I brought the router back up on the console here, it was in the middle of NHRP messages because we had debug on for that as well. And then this is like the database getting updated for NHRP. This is the 192.168.10.2. That's the tunnel IP for R1. That's its public IP. So the database is getting populated. And it's even saying, like, so at this point in the messages, it was already in the database. And what I noticed is, like, if you just leave this debug running, you'll just see that every so often there's, it's like querying it's sending messages to the HQ hub, and there's nothing really changing. And I think, I haven't looked into this too much yet, but I think the like delay and this IP NHRP hold time will affect how often these kind of messages come up. So let's see. And then this right here is the 30.50.60.1, 192.168.10.1. That's the mapping from public and tunnel IP for the HQ hub. Shows some bytes going out the tunnel interface. So this is all looking good. So I mean, at this point, basically, we have everything is established and working between the hub, HQ, and the initial first spoke here, R1. So if I do show crypto ISACamp SA, we see the tunnels up. Show crypto IPsec SA. There's been 92, 93 NCAPs and DCAPs happening on there. And that basically, since we haven't sent any traffic from a Linux host yet, I think that's just all NHRP stuff. And so like the things going across this DMVPN tunnel at this point would be like the NHRP stuff, EIGRP, and I think that's pretty much it. So we got a bunch of debug messages coming up. Actually, there's a whole bunch of, so this is still part of interestingly enough, when I did show crypto IPsec SA, the normal stuff that you expect for NCAPs and DCAPs, but then there's a bunch of other interesting messages that go along with this with NHRP. We've kind of covered that already, but if I just keep hitting spacebar and see the whole thing, there's a lot of information here, and that was just strictly from this IPsec SA. So extra information that you would that's specific to like NHRP and DH or DMVPN that you wouldn't see on a normal like site to site tunnel, for instance. So some other commands to run would be like we could do show DMVPN, and then right now there's just the one spoke, and then when we do this later, it'll show R2. When we get R2 configured, it'll be in the database there. We could do show IPNH RP NHS detail, and I think this will show on the hub. Okay, no, it doesn't show on the hub, but if we do it on here on the spoke, show IPNH RP NHS detail, and then so it's just basically showing the information for tunnel 0, 4 requests sent, received 3 replies, no failures. So I think that's just basically R1 kind of polling the HQ hub for this NHRP protocol. We can do show DMVPN. Same info as on as on the other router. Yeah. So now we can move to, well, let's see if this Linux host came up. And then, yeah, so I got DHCP assignment. We'll use that in a minute here. So now we'll just move on to R2. So pretty much R2 is going to be exactly the same as R1. The only difference obviously are interfaces, but as far as like crypto, it's exactly the same because again, this is a spoke that's only really communicating with the hub. So we got a pre-shared key just for the hub. Got to have the network for the tunnel interfaces so we can get the EIG RP adjacency. And then I'm going to advertise the interface for the LAN subnet. Same concept with the static routing. All this stuff in the tunnel interface is exactly the same. Putting in, oh, sorry, I was showing R2, but at any rate, R2 is pretty much exactly the same. So let's see here. Copy in all this stuff for R2 up to the IP route. And then the static route, tunnel interface, and DHCP config. And then as that's pasting in, let's look at the debug on HQ. Now we got another tunnel building. So R2 got configured, and then as soon as those commands went in on R2, then on HQ the hub, we're seeing the tunnel build from the spoke of R2. So this is going through tunnels building. And then on R2, we have the EIGRP adjacency as expected. And And then we can see the 168.5.10.1, which is the public IP for R2. QM idle, so the tunnel's up. Now we're getting into IPsec proposals, phase 2. And this is kind of the part that was missed when we were looking before on the debug messages, but we're getting directly into some pretty nice messages with the phase 2. I like how it's showing the transform set that's going on here. Bunch of IPsec messages that are helpful if something was not working. And then here pretty soon this should be totally done. Now we're seeing some NHRP messages, kind of like before. Because basically GRE tunnel is up, IPsec tunnel to protect it is up, and then NHRP messages coming across generated by R2, those requests coming across to the hub. And then this is probably all up here. So we can take a look at show DMVPN. Got the tunnel up with the hub HQ. Show crypto ISACamp SA. Got the tunnel up. Show crypto IPsec SA. Got NCAPs and DCAPs as expected. Show IP NHRP NHS detail. And at this point, one request sent, one reply received, nothing failed. Showing the stats, interface state event stats up, so up, down, deleted. So there's one event of the interface going up. And if I go back to HQ, I'm gonna do like no debug all, because we've seen all the messages you want to see, everything's working. But if we do show DMVPN, now we have 2 tunnels, one for each spoke. And then so now I'll bring up the Linux host, which is on R2's LAN subnet, and then we'll take a look at traceroute and some pings to kind of prove and show how, like, so basically what I'm going to expect is, like, I'll send a ping from the Linux host on the far left. It's going to, I expect it to hit the default gateway for its LAN subnet. And then that it's going to be destined for the IP address of the Linux host on the far right. It's going to hit the tunnel interface on the HQ router, and then it's going to hit the tunnel interface on R2, and then hit the Linux host. So this is everything that's going to go across from R1's LAN subnet to R2's LAN subnet is always going to go through the HQ router, because this is phase 1 and just hub and spoke only kind of topology or setup. And before we do that, so I'll do like show IP route, and we've learned through EIGRP that, how do I get to 10.5.10.0? From the context of R1, how do I get to this subnet here, which is the LAN subnet on R2? Well, I do that over the tunnel interface. And so, and then one thing I didn't do earlier, like show IP interface brief. Haven't had any problems with the tunnel interface coming up, but just to show that for being thorough. So basically, let's take a look at this Linux host. .5.10.2. So I'm going to ping 10.5.10.2. And then I, sure enough, have traffic. And then again, like 10.5.10, how do I get to that network? Learned that through EIGRP over the DMVPN tunnel. And then do a trace route for 10.5.10.2. So then, so if we look at the routing table for this, so 10.16.30.1 is the default gateway for the Linux host. 192.168.10.1 is the tunnel interface for HQ, the hub. 192.168.10.3 is the tunnel interface for R2. And then the IP final destination. So we know for sure that DMVPN is up, hub and spoke, and we have routing to this 10.5.10.2. Learned that through EIGRP, which those routing updates are coming across the same tunnel, and then there's no way to reach this 10.5.10.2 except through going through the DMVPN. And then we'll find the same thing on this one. So we want to ping we want to ping 10.16.30.2. So if we look at this, we'll do show IP route 10.16.30.0/29. Learned that through EIGRP, and we're gonna use the tunnel interface to get there. So then we want to ping 10.16.30.2. Which we get a ping 10.16.30.2. We'll trace to that, and then again we're going to see Linux host on the far right is pinging the Linux host on the far left. We see, so we're on the Linux host on the far right. The trace route shows its default gateway like we'd expect. And then 192.168.10.1 tunnel interface for the hub router HQ. Then 192.168.10.2, which is the tunnel interface for R1, and then final destination. So hopefully that was helpful. Next video is going to be the same hub and spoke topology, except for we'll modify the example for IKEv2. And catch you in the next one. Thanks.